Okay, so I'm recording myself. I'm going to model a vacuum former for the visors for the astronaut helmets. So I guess I can show you what those look like. Alright, so if we go to the helmet assembly, so this is the visor. Oops, kind of see there. And it's, well, I don't know. I guess I could pull some dimensions from it. So like from side to side, it's going to be roughly 10 inches. And then from like the top here to the bottom here, it's about 12 inches. So in order to get a big enough bed that we're not like right up against the edges of it, I'm probably going to design the vacuum former to be about 2 by 2 feet. And that way, if we want to make them from smaller sheets, we can like window it down. But if we want to make like potentially 2 at a time or something like that, we should be able to do that with a 24 by 24 bed. So first thing I'll do is I'll model up the sheet that we would be forming. It's pretty easy. It's just a 24 by 24 by up to 1/4 inch sheet. Oops, those are all. So this would be 24. Yeah, would be 24. And then check that off. Extrude. So this is the size of stock material that you'd be making it from, to give an example. Is it that? Oh, no. There we go. We'll go ahead and change the material. Make it polycarbonate. Okay. Let's see. Easy sheet. Okay. So now that we've assigned the material, we can get the basic properties. So it weighs about 6 pounds. It's about 144 cubic inches. Cool. So it's pretty handy. So the first thing we need to do, if the material sheet is this size, we need to clamp it on the edges somehow. I guess we should put together some of the requirements for this. So I started a tab on this already. This will be how big of a sheet it can accommodate. We'll probably do a few different materials, and then we'll go up to 1/4 inch thick. This could be thick enough that it needs to be heated from both sides so that it doesn't like sag, or well, so that it gets thoroughly warm. But then if you have to heat from the top and the bottom, it can sag into the heating elements when it gets to the right temperature for forming. So some higher end commercial vacuum formers will actually pressurize the bottom side to like take the sag out. That means the whole bottom enclosure has to be pressure tight though, which is maybe a little bit more than I want to do right now. That's like going to add a substantial amount of heft because that's going to be a pretty big volume that you would have to enclose. So I'm probably going to try seeing how thick I'll like make it to where I can hold a 1/4 inch sheet, and we'll see whether or not I can get away with it when I'm doing the actual forming. The other thing that's tricky with polycarbonate is you really need to dry it out before you form it. So I might, and usually when you do that, you want to hang the sheet vertically, like from the top edge, and put it in an oven. But I don't really have an oven that can fit a sheet like that. Or, well, I do, but making the fixture to hang it and everything, kind of a pain. So what I might do is have the heating element thing be able to like tip up and then have some sort of oven like insulative box that kind of fits over it, so you can dry the sheet with the same heating elements. We'll see how that works. I don't know. And then for heating elements, you want to use medium wavelength IR, like ports. Finding those is like hard. Heating sensor. There's a type of sensor called like a pyrometer. And so these are basically good for measuring how hot something is at a distance. And there's a whole bunch of different ones you can get. It's fancy to have a few throughout the sheet so that you can actually like pick up, you know, is it consistently all the way to the edges good. Also, sometimes it's good to have zone heaters so that you can like, you'll get like uneven heating if you don't control different parts of the square, because the heat doesn't radiate in a square, it radiates like in a circle, so or like a dome. So being able to control, like if there's one area that tends to get hotter in your design, to be able to control that independently is good. And the pyrometers can tell you kind of, these are like handheld ones, but you probably want one that's more like a probe. Oh yeah, it might be hard to find one that works good for, but yeah, so one of the big drivers here is it needs to be relatively low cost. Let's actually make that closer to like $2,000 because I don't have a lot of money to spend on this right now. So yeah, we'll want some sort of pyrometer here. Maybe that's like an eBay thing. Usually these controllers are just bang bang. Zone potentially, or just a timer. Max temp. Let's see. So we're like just below 200 C. Well, yeah, I found this page before. It's pretty good. Here's like a little video. Look at that. Looking slick. Oh wow, this is the most English description. Yeah, so here's like a kind of a diagram of what one of these things usually looks like. So you've got a mold on the bottom. We're probably gonna do positive molds, not negative molds. Then you've got a clamp on the top, and your vacuum pump sucks down and over the mold basically. So pressure forming would be super cool, but that requires this thick-walled pressure vessel at the top, which we aren't going to do. So pre-dry should be 125 C, it says. Trapped moisture tends to form vapor above 250 F, making the vapor expansion to create bubbles in the sheet. Dehumidifying air circulating oven. Okay, so we'd have to have some kind of fan. You need 1 inch between sheets. And then it immediately starts absorbing. So we pretty much have to go straight from the oven to the forming process. I'll go ahead and take some notes here. Dry show. Okay, so the nominal temp for forming, it looked like it was 180 and 190 C. So one of the tricks you can do to get more even heating is in the middle kind of area where you would tend to get more heat. You can put like a little deflector plate like in the oven that's like between the heating element and the plastic, and that way you don't get like overheating in the middle and then no heating at the edges. It sort of like helps even it out. But like figuring out exactly how big that plate is, from my understanding, is a little bit of trial and error. Maybe we could just do some DeWitt heat and mass transfer calculations and like try and figure out the radiative heat transfer in the window, but to actually do the real math involves, it gets pretty complicated with radiation because like the view area matters a lot, and then there's some other, you get re-radiation from other things that heat up, so it's not just like a fairly straightforward hand calc. It's probably easier just to trial and error it because you're just cutting out some different size sheets and swapping them out. Okay, so we want it to be on the order of 180 to 190 C. The nice thing about that is it's like a low enough temperature that a lot of materials are pretty fine in that range. Like there'll be some plastics and elastomers for seals and stuff that are okay with that, especially considering the main thing that's going to be 190 C is the sheet itself and not like every component of the oven. There'll be some insulation. So yeah. So usually these things are 233 phase or 230 single, or sorry, 480. Well, industrial ones are 480. The home gamer biggest ones are like 233 phase, but I only have single phase in the garage and I don't want to put a VFD on it. So it's probably going to be 230 single phase, or it's going to be 2 110 circuits, because the biggest breaker you can put on a circuit breaker is not enough to drive the heaters for one of these usually with one 110 circuit. So you split it across two and you just have two plugs. The garage I'm working in does have 230 single phase. I'm kind of maxed out on my breakers right now though, so I do have sort of like an accessory plug that can do up to 50 amps, so that might be where it ends up going. We'll see. It should be interesting. You know, one thing that's interesting is like how heavy is the mold? Because if we're making them, a lot of hobbyists and stuff make them out of like wood and Bondo, like particle board on a router, and then they glue it together and then Bondo it and then like hand smooth it and polish it. I'm thinking I might do aluminum just since I have the mill and I can cut it. It kind of depends on whether or not I can get stock material cheap enough, but IMS, Industrial Metal Supply, has like cheap stock available, so I might just see if that works. If not, you know, it'll be less heavy, so that's probably easier. The other kind of cool thing you can do is you can preheat the mold. I could put like liquid channels in it and like flow hot water through it, or do hot water, and then as soon as it's done molding, I could flow cool water through it to like quickly set the plastic. So there's some cool things you can do if you have like the internal plumbing kind of machined in there. But it's a lot trickier to do that, and you're already going to need some holes to pass through the mold to allow the vacuum to like get to every part of the surface. Like usually you have some like little pinholes that you drill through. So figuring out how to do those is probably an interesting problem. We'll see. I'm going to work on that. And also usually you don't want the mold edges to be sitting right on the surface of whatever your platen is, because you'll get like a little bit of webbing. So you want to you kind of want like a riser that stands at maybe an inch off of that bottom surface so that any webbing happens off the part and you're not scrapping parts. And the last kind of thing is you want to be able to, like, it's nice if you can trim with a CNC because you can get a really nice edge all the way around. You can hand trim and Dremel, but it's going to look worse. So to figure out the max mold weight, I'll just assume that this visor is like one of the bigger things I'm going to be doing, which might be a bad assumption. But I'm going to make it anyway because I really don't want to over design the crap out of this thing. So I made oh, this is like a different backformer. I made a mold volume, I think, at one point for the visor. If I just turn everything on, it'll probably show up, but that's the lens. So this is how big I think the volume of it would have to be. And I think it's like, let's see, it's like 15 by 15. And that's plenty big. So 24 by 24 is kind of overkill, but I think it's one of those things where, like, if I'm going to go through all the process of building a vacuum former, I might as well make it big enough to do other stuff on it. Let's see here. I wonder if I can just show all parts and I can find it, maybe. Got a bunch of random volumes. Oh, maybe it's not in this one. I might have never made it for this one. Well, that's fine. I could just make a new one really quick. So let's go ahead and what we'll do is we'll turn everything off except for the visor, because there's a lot of stuff going on here. Hide other parts. Go ahead and hide all the planes and hide all the sketches. There you go. Here, for some reason, this must be like a composite curve or something. Yeah. Hide all the curves. Thought I hit all the planes. Must just be freaking out. Okay. So what we can do is we can make a... Oh, I guess this isn't... Well, that's kind of annoying. So you can make part studios in context in here, but you have to be in an assembly. So one of the things, making assemblies and parts different is one of the things that's really unfortunate about both SolidWorks and Onshape. Because when you have different file types, you basically immediately have this like really awful problem, the fact that like a lot of parts turn into assemblies and assemblies get merged together and turned into parts, and transitioning back and forth between those can be really hard if you've built up a pretty big feature tree and then you realize like, oh, this needs to be a weldment. You pretty much have to start over in programs like this. In a program like NX, you can just merge them all together and a part is an assembly, so it doesn't matter. Like you're just done. But it also makes it harder to do things like when you're cutting a hole through multiple parts, like match drilling something, which is very common. Controlling that hole across the parts means you need to establish a new assembly context for a part. And the way it works in Onshape is it's sort of managed on an individual context basis, and you can update each context like manually. I don't know if any CAD program does this particularly well, but NX at least has something called wavelength geometry where you can basically do something like that and then break the link. And that makes it to where you won't have someone accidentally come through and update like a wavelength assembly and then have it cascade into all these other parts that you weren't paying attention. The Onshape kind of way of dealing with that is through they have like a, I don't know why I didn't mean to make this. It was just a fat finger. Cancel that. Oh boy. I guess that sucks. Anyway, yeah, doing wavelength parts, you just have to come up with like a way that's internally consistent at whatever company you're at or within your own like brain if you're not working with other people, so that you don't end up in a place where you have issues. And the way Onshape kind of tracks it is it has like a Git style version history, so you can sort of unfuck yourself if you manage to save versions off. Oh my god, I definitely didn't want all of that. Let's go ahead and cancel this insert and let me cancel without. That's nice. Okay, so I just wanted this. We'll go ahead and move that there, and then we'll want to place this guy at the origin. So Christ knows if I can find some kind of origin here. Probably not. No. Yeah, sure, that's fine. Whatever. Put that there. There we go. Perfect. Okay. So now what we'll do, now that we have an assembly, we'll call this mold assembly. Mold assembly. And since the vacuum former is kind of different from the helmet itself, like I'm gonna just make the mold in the Catstronaut file, then I'll go back later and do the rest. So there's one question of like, well, where do you put the flat part, right? Like I could have it to where gravity down on the mold is this way. But usually what you want to do is you actually want to find like the center of whatever the biggest arc is and then go normal to that. And that way it would be more like something like this. And the reason you want to do that is the plastic doesn't have to stretch as much, usually, if you're doing that. And the thing is, like, when you go to mold, the plastic, it's hot, so it yields and moves, but there's still some Poisson's ratio stuff going on where it wants to, like, thin out in some places where it's seeing higher stress. And then you get an uneven thickness and you get optical aberrations effectively. So it'll look kind of like watery or wavy through the thin spots as they transition to the thicker spots. And for something that you need to be optically clear and you want to kind of forget that it's there, that's not good. So the smoother you can get the surface, and then the better you can get the material thickness to be even and consistent throughout the part, the better off you are. So you kind of want as little stretching as you can get. Some things that can help with that, I guess, if you pressure form, it can do better at maintaining uniform thickness. Probably also like really even heating. And I imagine even your fixity method matters a lot. Like if you're just grabbing on like 4 square edges versus like something that more conformal to the actual shape of the visor and might have like additional material kind of where there's going to be more stretch, that's probably what you want. Okay, so to get that normal vector, I think I'm going to sketch. So the first thing I have to do to create a Part Studio in context, usually you want to make a mate connector for that so that you know what it's attached to, kind of. This one will be fine. And then we'll go ahead and create a Part Studio. Oh, well, I just did all that, so there we go. All right, so you can kind of see there's like this ghosted version of the visor now. And so I'm going to go ahead and sketch on the right plane here. And we're going to grab that curvature by using this edge here. So look at that. It created the context. Great. Okay. So one of the kind of cool things about the constraints here is they have one that's just normal to curve, I think. So we want to find the midpoint, which is probably like, I don't know, whatever. We can just draw a line, and then we can just take this and say that it's midpoint of this. Midpoint. Oh, come on. This guy. Midpoint. Oh, that's like a spline. They got me. Nailed them. What about this? Pierce. We pierce that. Oh, some of the entities cannot be used. So one problem with Onshape is it treats splines as a different class than lines and curves. And in most CAD systems that are non-uniform rational Bezier spline based, a curve, a line, a point, it's all just represented as a Bezier curve. So like a spline is a spline, is a spline, is a line, is a curve, is an arc, is a circle, is a whatever. Like they're all defined the same way. Onshape has like a different class of geometry article for a spline surface, like anything that has complex curvature versus just a 3-point arc, a curve, 3-point arc, a fillet, a circle, a chamfer. Like all those are considered lines and curves, and then splines are this totally different thing. And then a lot of the like constraint methods and sketches and all this other stuff doesn't work on the splines. It just works on lines and curves, which is frustrating as hell because I know exactly what I want to do. So I can make this normal, like that works. But then if I want to grab the midpoint, and I mean the thing is, a spline has a midpoint. Like, why can't it calculate the midpoint? Great question. Like, come on, guys. Like, and the worst thing is I could probably even. So like, yeah, it won't do a midpoint between those two. So I could probably even just come in here and make a 3-point arc that like very closely approximates this. Like, look at that. It's like pretty close. And then I could just take the midpoint of that. But then that's not the midpoint, which is really annoying. So there's the midpoint-ish. We could do that. So then this is like roughly the normal vector of the midpoint of this. And so what that lets us do, so I'm going to go ahead and make the fake one a construction just so I know that it's like not the real one. But what that's going to let us do is now I can set like an offset distance. So let's say like, I don't know, we want to go maybe like an inch past that edge there. So actually I'm going to kill that. Then I'm going to come down here and I'm going to basically take a perpendicular line that is coming right to that edge there. So I think I can grab this edge, and I know it's a spline edge, but I should be able to do it coinciding. Oh man, see, so stupid. It's like beyond stupid. Anyway, so it did something to attach it. Oh yeah, there we go. Okay, so like kind of have to, I wonder if I can make it tangent. That would be nice. Oh yeah, there we go. Okay. So now we have some construction geometry here, so we can say, okay, like how far off the bottom are we going to be? And I'll just go ahead and make this like, I don't know. Let's make it 1.5 inches maybe. Yeah, that seems like enough. Okay, so if we were to look at this dead on from the side, you can kind of see we're like 1.5 inches down. So we're going to go ahead and make a plane on that point. So, or sorry, actually I want a curve point. So like this is my curve, this is my point, and look at that. So this would be the plane of the base of the mold. We can go ahead and sketch on that, and we can project these curves down to it of the edges of this guy. We actually want to make sure we get the actual like edge curves and not just the interfaces, because there's actually like little edge face that would be pointed down. You can see my curvature is not entirely continuous. There is some like, I don't know, interruptedness to it. Okay, so there's my base. So what I can do now, so if I go ahead and check that box, I can extrude this base up. It's probably a faster way to do some of this, but I'm just going at it. All right, so 1.5 inches. So this is just to touching the bottom, right? Now, usually you want it to be, I'm trying to think. So like if we go to 1 inch, right? We can do something a little bit interesting. So we'll go to 1 inch, and then, oh, I missed this segment. My bad. There we go. So if we go to 1 inch, we're the same size as it right now, but we probably actually want to be a little bit bigger. So we can use, this is like synchronous modeling stuff, like we can move faces. So if we select all the tangent faces, and those, because, you know, yeah, if we make it like a 1/4 inch bigger or something, that just gives us some trim margin. So basically there's like a clear, you want there to be like a clear edge that you trim off, but you still kind of want like a smoothish profile, because if you don't have some kind of draft or something like that, then you'll end up with like, it gets stuck on the mold and it drags when you try and pull it off, and it like scratches the inside of it basically. So we'll go ahead and offset that. And, oh God, what's this? This is like some kind of sliver bullshit going on here. I don't like it. I don't like it. What's wrong with you? Is there like a very slight, I'm gonna hide this for now. Is there like a slight difference in these curves? Oh yeah, there it is. There it is. So fucking annoying. Okay, so let's go back to this. Why is there a difference there? Is there actually like a third little edge there? I don't see another edge there. All right, well, here's what we'll do. We'll go ahead and we'll just delete the inner curves, because we don't actually need those. Those are just kind of not really helping us out anyway here. When you project, it's like more of a pain to select every little thing that you want than it is to just say, here's the whole face, grab it. Then you get these weird little geometry errors sometimes. And part of it has to do with probably how I designed the visor itself, but that was a while ago, and I'm not going to go back and redo that so that it's super clean. I'm just going to like deal with the mess. So go ahead and delete all those internal curves so that we're not missing any little sections when we do the extrude, and this will probably break the extrude and I'll have to change it, but we will make this construction because we don't actually need the center line there. Oh, and there's a second center line, which is annoying. Probably because I did both sides. And we'll just delete and then we'll do construction. There's another one in there. Anyway, overlapping edges. Yeah, and I mean, a lot of this clean geometry stuff, like, if you're really good at using the program, you'll always end up with clean geometry. But if you're like me and you don't use Onshape as much as you've used like NX, you get in these habits of doing it the way that you did in the other program, and they create like little problems for you later, which is kind of annoying. Okay, so then, you know, we kind of have a nice little base here. Now, it's probably a good idea to go ahead and make a bounding box actually of this, because I mean, let's make a bounding box on this plane, because you know, it's good to know how big of a piece of aluminum we're going to have to buy. Oh, that's interesting. Is that not? Oh, I guess this isn't looking at front. Oh wait, no, I'm confused. Oh wait, yeah, okay, that's fine. So you know, we're gonna have to make this out of a piece of aluminum, and I don't want to spend a lot of money. So if we can make it out of something that's like a reasonable size, so this is like 11.5. So we probably need a block that's like 12 by. Can I fit it in 12? No, that sucks. Oh wait, can I fit the visor in 12? Oh, I totally can. Ooh, but it's just barely. That's probably fine. So we have a 12 by 12 block. How high does it have to be? So like from here down to here. 6 inches. So 12 by 12 by 6. Aluminum planks or billet. Let's see, 12 by 12 by 6. Oh, 12 by 12 by 2, $420. Holy guacamole. How about these guys? I need a big old chunk. Oh, these are all architectural bullshit. I mean, really, I'm going to go to IMS and look around the scrap area to see if I can find something, but that's a pretty big piece of scrap. Oh, there it is, 12 by 12 by 6. Oh, that's an enclosure. Well, anyway, I'm not going to... The internet's the worst place to find material. Or it's like a pain in the ass. Okay, so 12 by 12. I mean, it'll fit on the mill. Getting the material is a little bit more of a pain, but we might be able to trim an inch off and get a 12 by 12 by 5 or something. Finding the exact piece might be a little tricky. It might be closer to like you get a bigger piece and then back down. But anyway, yeah, it does seem doable. So what we'll go ahead and do, just to save ourselves a little bit of headache, is that gonna fit? Oh yeah, it'll definitely fit. So I guess I should probably make this actually centered so that I can use it to trim the base. Oh, what is actually, oh, cool. All right, go ahead and do that. And then I'll just trim off the front and the back where that is, because I don't want, I'll just make some trim surfaces here and then. Hooray. Take those little surfaces, and then we just do split this, split with this. You don't keep both sides. There we go. Perfect. And then we can do that the same on the other side. So I might end up redoing this mold just based on what material I can find. But for now, this will be the starting point that we're just going to assume for the vacuum former. Okay, cool. All right, so now I kind of have like a base. So the first thing I need to do is add a draft to that, because right now there's no draft and that's going to suck. So we'll go ahead in here and we'll pick this as the neutral plane, and then we will draft. We'll select tangents, this guy, get the tangent there. Oh, god damn it. There we go. And then we got one more. Okay. So you kind of see when you do the draft, it leans in a little bit. We'll just go ahead and do like a 4-degree draft because, oh wait, is it going? Oh, it's leaning out. I'm going to go the other way. There we go, leaning in. Yeah, 4 degrees is probably fine. I mean, we could go more. Like, it's not, we got plenty of margin on the edges there. That's kind of why I did the offset so big. It looks more like this. Yeah, why not? Let's do like 6 degrees or something. So what I should do is I should set up a view that looks straight down this and like save it off. And I think there's a way to do that in here. Maybe it's like, I don't know. I guess we could search save view. Oh, that, I don't know why I put on shape. Oh, well, that's not super useful. Oh wait, that's searching through the feature studios. That's not the actual help. Oh fuck, the internet's gonna be better at this. Save view on shape. Named views. Let's see. Line view to curve on shape. View combination of features and tools. Use the view cube and key. Face of the part containing the end key. Select the curve, align the view. Use the view cube. Face you want an end. Oh, okay. So I just need to go normal to that face. And then I can go view tools, name views. Okay, so if I do, I've never really done this before. Named view. No, it's not in there. That's not super helpful. Search tools named view. Totally worthless. Oh wait, maybe it's over here on the appearance panel or something. Duration. Let's see here. Help. Named view. And views. Oh. View tools menu. Oh, it's there? I didn't see it. Maybe I'm blind. I'm blind. There it is. Okay, cool. So I should be able to just click on this face, hit the N key, and look normal to it. And then I can come over here and do named views. And I will call this like top mode view. And then I can just like do stuff over here and I can be bam and then get back to it. That's cool. All right, nice. That's all I needed. Okay, cool. So now that I can actually look normal to that and see, yes, so I still have a little bit of margin. I'm just checking to make sure that even with the draft angle, I have some margin on where that edge is because I don't want to go off the edge of the material. So the next thing I'll do is I will go ahead and extrude this top surface up until I hit at least that line, right? So let's go ahead and we'll just do a solid, and we'll pick this whole thing. And we're not going to do any draft this time. We're just going to go straight. Let's just say 6 inches. Probably fine. Yep, that's fine. Okay, cool. So we have that. Now we just need to chop the top off. And the easiest way to do that I've found, is by hiding this guy and then creating an offset surface on the inside here, like that. That's not offset at all, but we'll actually grab these edges too because they matter. You matter, edges. All right, I'm gonna go ahead and get the rest of these guys back there and there and there. All right, cool. So now we have a surface, and we can go ahead and hide the visor. Oh wait, did we hide the visor? Where's the visor? Oh, okay. We're just looking at the context, so we can change the context to nothing. Now this is just a surface. So if you notice, like, because we grabbed those edges that would actually land on, that's like where you want it. That's where the trim line should be, right? So if you're molding it, what you want to do is come out a little bit from where the trim line is, like this. So what we can do is we can move the boundary out a little bit, and this will just move it like tangent to the surface. And we're only really need to do like maybe 1/8 of an inch or something, like not a lot. And then what we're going to do is the harder thing, which is to extend it back in the same direction as kind of this guy. So, and I don't know how I'm going to do that. I haven't figured that out yet. Okay, so there's that. I guess what we could do is we could just measure one of these curves. That's 0.246. So are all of these 0.246? 0.243. 0.243. Okay, so maybe we just pick the shortest one. 0.243. Let's check this one. 0.243. Okay, so we could do an offset and a move boundary. Offset these guys this way. 0.243. So that gets us out to there. Ow. Bit my finger. You had a carpal tunnel, bit my finger. Okay, so now this is sort of like the top, but we don't actually want the inside part of this. We just want to make like a move boundary on the outside of this guy. Oh, can I just actually, you know what? Undo that. We'll just pick that whole surface and this whole surface. Cool. So that is there. And now, how am I going to trim that? So now what I want is I just want this part over, this skirt over here to cut the bigger part, and I don't want this inside part. I wonder if I can split that the way it is. It might. I don't think it actually fully intersects it though. So like if I split this and I use these guys, yeah, see, it doesn't like fully intersect. Oh, you know, actually, when I do that move boundary here, I shouldn't pick the whole surface. I should pick edges. I should just pick the outside edges. Oh, no, I don't want those edges. Get that. There we go. Okay, cool. That works. Okay, so that one, and then I wonder if I can just do both at the same time. Oh. Nope. Oh, wait. No, it's doing that thing again. Oh. Oh, boy. I also don't like the other object selection tool in Onshape very much. Okay, so this might work. Oh, well, Maybe not. Oh wait, no. I can turn these guys back on. Okay, so then I just need to split this guy, and I want to use this guy and this guy. This guy and this guy and this guy. Oh, it doesn't let me. It doesn't let me pick more than one fate. That's some hot garbage. All right, so what do I gotta do here? I wonder if I can like merge those surfaces together. Is there like a? There's no like sew feature, I don't think. Oh, you know what? You know what? Maybe it doesn't matter. Yeah, I don't think it matters. Okay, so now we go back to our part, and you can see that kind of intersects it. We need to go a little bit further to actually get all the way through it. So we're gonna amp this up to like 1.5 inches. No. We want it to go all the way through 2 inches. Oh, that's unfortunate, but okay, it's acceptable. Unfortunate, but acceptable. Okay, so what we're gonna do first is we will split this by this. Oops. Oh no. Oh bother. Can I do face? Oh no. Oh man. That's one thing I really hate about this is it doesn't. So I guess we could maybe do like an offset surface and make this one surface. Okay. Yeah, that says it's one surface now. So we split part 1 by offset surface 3. Damn it. This surface. No. Why aren't they the same? They should be the same. So stupid. Oh man. Let's see if there's like on-shape merge surfaces. Okay. I don't want to use a feature script. Oh, god damn it. Oh, maybe just a Boolean does it. Bingo bango. Well, the Boolean didn't fail. Oh, yeah, there it is. Okay, so now split part entity to split with surface. Bam! I don't want to keep both sides. That's fine. Oh, I guess we turn the part back on. Okay, cool. So now, if we go ahead and hide these guys because they don't really matter anymore. So many extra surfaces, but whatever. Okay, cool. So now we have part of a mold. The next thing we need to do is split the mold. Basically need to like carve out. I wonder if I could just offset. Oh wait, no, those aren't really split faces yet. Okay, so we're gonna go ahead and split this guy, and we're gonna use. Oh, it's too many surfaces, but what I might be able to do is do an offset and then just offset them all in one. Or, oh, I can Boolean them all together. Boolean. Boolean. Okay, one more, 2 more. Don't fail me now. All right, cool, we did it. So now we made that, and now we can just kind of pop the part back on. See how long this shit takes? Holy crap. All right, so we're gonna split that guy. We're gonna use the Boolean. The Boolean. We don't want to keep both sides. Look at that. We're trimming like nobody's business. We'll just hide all these surfaces because we don't really need them. There we go. So there's our mold. So one note here is what'll happen is it'll like suck down in along this edge line. We'll actually want there to be like holes that go in around here. Otherwise it won't draw in very well. But we can put some holes in there. Like, it shouldn't be too bad. The other thing that's kind of tricky is with this specific geometry, you're not actually going to have a sharp edge here. Like, there's just no way. That'll come from trimming. So what we'll likely actually do is like offset that a little bit. This sharp thing here is some bullshit too. Like that's probably not going to work. So I'll have to round that out a little bit. But the other thing that's like a little funny is I don't really have mounting features in this visor yet. I probably should have some. So it might make sense to sort of have some like locating holes or something like that I can like either drill after the fact or like at least have a visual indication of where they should be in the mold. But this is like a good starting point. Kind of gives you an idea of maybe what it would look like. So there's our kind of janky mold that's sort of representative. Might actually need to get a longer piece of aluminum to do this, maybe like a 12 by 14 or a 12 by 16, but we'll see what's available. It could also be that I make it from a couple pieces of stock and then just sort of like bolt them together and then machine them after they're bolted together and hope that the seam, or never take them apart. But it does go through heating cycles, so it would be nice if it was made out of one piece. And not a bunch. So anyway, this is our mold V0. Nice. So the next thing I'm going to do is go ahead and pull that into our vacuum former model. So we have a part studio, and this we can just call like material. I don't know. And then we'll call this our mock-up assembly. CatVac. I'm calling it the CatVac because it's for the Castronaut helmet. So, okay, so let's go ahead and we'll put in our sheet like that, and then we're gonna go over to the Catstronaut, and there we go. I think, where is it? Oh, okay, so I'm going to go to owned by me, and then Swarf, and then Swarf Castronaut, because that's the one that I'm working in now. And where did I put it? Did I call it something? Oh, I need to create a new version, so I'll go ahead and do that. Oh, yeah, I guess it was in an assembly. Oh, yeah, I should rename this. So we're going to call this mold. That mold. Okay. Call this that. Oh, you know what? Actually, visor. Because I will not know what vac mold it is. At some point, I should probably also mold the little lenses that go over the ears and stuff. Because, like, I don't know. This is the helmet here, actually, that we're making this visor for. So I guess I could. Ah, there you go. There's ones that are actually have the LEDs on them up there, but okay. So let's go back over to the CatVac former, and we're gonna go here. I guess we have to create a version. Create. And close that. So one nice thing is you can just sort of close windows and not worry as much about things saving, like, because it just always saves. The downside is you might accidentally like screw up some feature, and then trying to figure out how to get back to it in a version that works is like, it could be a huge pain. So, all right, so we're just gonna grab that sheet, and then, you know, we should make this transparent or something, because like it's not actually going to be appearance. So one thing that kind of sucks is the appearances aren't tied to, I'll do like a blue. The appearances aren't tied to the material properties per se. There might be a way to do that, but by default you have to like assign them independently. Okay, so I'm pretty sure I was working on Smart Astronaut. It's funny that it takes so long for it to load the parts list. Like, the bond table shouldn't have anything to do with the complexity of the parts themselves. Unless it's like trying to generate the previews. Oh, yeah, it's trying to generate the previews still. Fuck, man. Okay, so there you go. Here's that. So we'll go ahead and mount this guy. Actually, we'll make the origin of the material at the origin, and then we'll go ahead and we'll put this guy. Well, there's a bunch of ways we can do this. I'm not going to do any constraints for it right now because I don't see the point. Though one or two might help just to get it aligned on a way that makes sense, but whatever. I'll just put it over here for now. Okay, so something like this, like that. Okay. So, oh fuck, that's my coffee all over my lap. I'll be right back. Ooh. Should have drank the coffee faster. Whoa. All right. Okay. I got most of it. Well, actually, I didn't get any of it. The copy on the desk. So, picking up Mr. Laptop over here. All under the keyboard. This desk has a nice shellacking of coffee stains from many spilled cups, so it's nothing new. Oh man, we've been going for about an hour now. I wonder how big the video file is. I guess it's 60 megabytes or 6 megabytes a second. So let's see here. There's 6 megabytes a second times 60 seconds in a minute times 60 minutes in an hour. So we're at 21,000 megabytes, which is 21 gigs ish. Not too bad. Okay. So the way this is going to work, kind of, sort of. I wonder if I can just move the handles on here. Oh yeah, I could totally do that. Where's the little bottom? There we go. Okay. So the way this is going to work is basically there'll be some kind of oven that is chilling over here on the right. I don't know if you can actually see what I'm gesticulating here. I'll put a new part studio at the origin for the frame. All right, so what's going to happen is basically we're going to have some kind of frame that looks like, I don't know, this. And let's say we want this thing like, I don't know, what's the normal desk height, like 32 inches off the ground or something? Okay, so that's like a normal desk. So let's say we want the top of that thing to be around where a normal desk is. And then we need an oven that's at least the same size as this. So we're going to have an oven that hangs out over here. And let's say it's like maybe 6 inches wider, so like 30-inch oven. Cool. So the ovens actually needs to be like a box like this. And it's got heating elements that kind of go in and out of the page. And they're like little quartz tubes usually. So like, let's just say we've got some tubes. And we'll just kind of throw them in there. They're not, this isn't supposed to be any kind of exact, oh God. It's supposed to be any kind of exact, but you get the idea. These little circles represent tubes. So basically what will happen is you'll put the sheet down. So the sheet will come from space and will go down. And then there will be some kind of clamping mechanism that goes here that clamps it down to the box. We'll call it some kind of clamping mechanism for now. And that will go all the way around. So that'll be like over here. Well, the little clamps. And it'll also be in and out of the page. So you have your little clamps that come down, and you'll put your mold in first. You'll clamp your material in. Now this is after it's been dried, so it might make sense to have the drying oven just over here on the right. So basically you like dry a piece and then you move it over here. It could also make sense to do like the drying on this side and then you move it over. I'm not really sure yet. Gotta think about it. But you need fans for that. So if you're going to do drying, you probably would have some kind of like fans up here somewhere, maybe like that, like big blowers. So anyway, now once you've got it dried and clamped in there and you have your mold down here, right? Then you're going to want to heat up the plastic until it gets hot enough. And when it heats up, it's going to sag. So you're going to have some kind of like, you know, saggy bullshit like this when it's all like done and warm. And it's probably like, I don't know, like that or something. So your mold can't be right up against the bottom. Otherwise, it'll sag into it. And then it'll get cold in the place where it touches and just bad stuff will happen. So in order to get it hot to make it sag, you have to have the oven placed over it. So you put the oven on some rails, and this is actually like a common design for these things. So you put the oven on a couple of linear rails, and you slide it over, and then the oven is over top of the sheet. So I guess it's like this kind of, if we want to just like mock it in there. So that's where the oven ends up. And we'll just put little dotted lines here so you know that it's not like there all the time. So anyway, it goes over, it sags, and then what you do is you have some kind of, I already fucked it up. Sorry, guys. All right, so you have some kind of, oh, that's really annoying. Okay, so you have some kind of platform that brings this guy up. And it's got to ride on some kind of rails, so there'll be like, you know, something like this that it rides on. And basically, you push this guy up like that. Usually, there's just a big lever, kind of like a slot machine. So like, I don't know, you'd have something like this maybe, or you have some, either some kind of cantilevered thing or like, I don't know, some kind of mechanism. I haven't really figured out how we do that. Oh, I guess the person probably can't stand where that is. So person's probably standing over on the left. So you have a big long arm that comes out there and a big old lever. Like I don't know, this or something. Let's just say it's like that for now. So like this lever would move in some kind of arc like that, like that. And this is not drawn to a good scale, but you kind of get the idea. This pivot point could be way up here or something. I don't really know. But you swing the lever down, the platform goes up, and then usually there's like a face seal about here. And imagine this is just an O-ring that goes all the way around. It's probably like a Visto thing, or just like, it could even just be like the kind of seal that you have on a door in your house, where it's just like that kind of foam rubber that's placed all the way around, because it just needs enough to get the vacuum started. So basically this seal goes and slams up onto a sealing surface here when it's all the way at the top. And then you've got a grid of holes that go through this thing. So it's kind of like this, where there's like little holes, and that's like oversized. It would be much smaller than that. But like, you get the idea. There's like a whole grid of holes on here on the entire platform. And you basically want to pull vacuum through those holes to like suck the material down onto the mold as it goes up, right? So you also would have little tiny holes in your mold that they don't necessarily need to line up, because you probably would have like a little cavity at the bottom of your mold so that all the holes are like kind of manifolded together, like this kind of. So like the inside of the base would be hollow like that. So anyway, you have like a port on the bottom somewhere, like over here, and you hook up a shop vac to the port. So the air goes out this way. And you leave the top open to the atmosphere. And basically what happens is the mold goes all the way up, the vacuum sucks the rest of the material down, and you end up with a part stretched over the mold. And as soon as, and obviously the heaters have been removed, so it's cooling rapidly. And once it cools, it hardens, and then you undo your clamps, you pop your plate off, and then you have to trim the excess. So, if the plate were actually 24 inches, you could probably get a couple out of that with the size that this one is, or maybe even 4 if you're like really pushing it. But, everything about how the plastic drapes around the edges and stuff is what really probably determines, like, you might need the mold to be a little bit bigger to get a clean part out. And that's fine. The other thing you can do is you can add like little window to down, like basically a smaller square than this, clamps. So you have like a little maybe 16 by 16 or 14 by 14 sheet of polycarb, and it's just like windowed down to the center, and that window just supports it out in the middle there. So that's another thing you can do. And then you design your machine to do the full size sheet, and then you can just add that tooling later to do smaller sheets and kind of save you on the waste. So anyway, so then there's a bunch of questions like, what do we make the frame out of? What are the heating elements? Like, what's the blower? Like, if you're going to dry the sheet in the oven, like, what does that look like? Like, you probably want that to be indirect heat. So you just want to, like, you might even have like the sheet hang out somewhere else, like over here, and the oven offset so that you're not directly heating the sheet and you're just blowing the hot air over it, because you only need it to be at like 200 C for that. It's also my understanding that you kind of want the sheet to hang vertically for that. So that could be something where like maybe we have like a little slot over here or something, and then we just have like some kind of duct. So like, let's say we have a big slot, and maybe we move this guy down or something. I don't know. Let's say we have a big slot that the whole sheet can fit in, and it could just hang from like a little clamp guy at the top. Like a little clamp guy for the sheet, like that or whatever. And it kind of slides in from the side. And then you'd make some kind of funnel thing over here that doesn't move with the oven. It's just like fixed. And when you blow the hot air, you basically heat the air in here. And, let's say there's like a really big, I don't know, some kind of like deflector plate thing, or a couple of them that sort of keep the radiant heat from going directly in, like insulators effectively. But you still allow for some airflow. And basically you would use these blower fans, blow the hot air in this box down across this guy to like dry it out. And you just run that for a while. And then when that's done, you pull the sheet out, stick it in the clamps over on the other side. And it would even be nice if you could like already have most of the clamps on the sheet when it's in this slot. and then you just pull the whole like clamped sheet out of here, and it just drops onto pins over here. And then you would bring the oven over and like heat it up until it gets to its glass transition, or I don't know. I don't think it's actually the glass transition point. I think it's like a softening point, like annealed effectively, like with metals. You get it to that point. Part of the thing too is like that's where you might have a pyrometer, or I've seen like little sensors that are over here, kind of. And that's tricky because like you got to make sure that they don't run into your platform, so they might have to be further over. In our case, like you might actually have the little sensors be here, and you just know how far it's supposed to sag based on like what kind of sheet it is. And once the sag breaks like a infrared beam or something, then you go, oh, okay, now there's enough sag, I'm good to go. A little green light comes on, and then you shove the oven out of the way and pull the platform up, right? Now, one thing you got to be really careful about is if you have a big manually operated lever like this and it's not like pneumatic or motorized, some asshole is going to push the lever down while the oven's still over here and like smoosh the plastic into the heating elements, which is like not what you want. So you need some kind of interlock basically that won't let the stage go up unless the oven is out of the way, all the way. And that's probably just a mechanical interlock. I'd have to think about how to design that, like, cause that's a bit of a mechanism, but, you know, you don't want to wreck your oven accidentally, like, especially if you're going fast and you're just trying to like pump a bunch of these things out and you have like an unskilled operator potentially, like an intern or something. It's good to make it idiot proof if you can. And then, you know, if your operator controls over here, you probably want some kind of like, if you're going to have a controller box or something just on there. It could also be on the oven somewhere, depending. I mean, you don't want it to be on the oven per se because that's going to be hot, but like, it would be nice if it were here because then you could have like your little like operator console thing here, and that's where you could set your temperature, your time. Like maybe if there's sensors, it could tell you, you know, this is how hot the sheet is, or that the sheet has sagged. It's time to go, right? You know, and then it has to fit in my garage somehow. So we're probably going to put wheels down here, I'm guessing. Something like this. I don't know. Just like a little wheelbase guy. So we'll want like caster wheels on the bottom of this or something so that it can roll around. So it's not stuck in one place, you know. So yeah, this is like my rough plan. So now's the part where I'm going to go offline, spend some time trying to find components, because a lot of this is going to get made from off-the-shelf stuff like McMaster, Granger, like anywhere I can find the heating elements and the controller stuff. And once I put a bit more of a BOM together, I'll come back and I'll actually start modeling things. I'll probably put all the vendor parts in first that I know of or that I think I'm going to use. And then I'll come back and lay everything out. And then once it's all laid out, I'll kind of do a first pass at like a frame and any kind of enclosure, and any like custom, mostly like brackets and stuff to hold the things together. So probably like anything that like holds it together, and then the enclosure. One thing that's like a little tricky is, you know, if this thing is getting shop vac on the bottom, like, does this whole bottom hold vacuum, or is there just like a hose that comes up to like a back manifold that rides on this plate or something, like, so that we're not pulling vacuum on such a large volume? The other thing that might happen too is we might have a vacuum pump and a roughing tank. So basically, like, imagine that this little square is like a vacuum pump. They kind of look like this, actually. It's like a little round guy. And then there's like a little stem like that. and there's like a little head guy. Kind of looks like a little electric motor. It's like a vacuum pump, and then this would be like, imagine like a keg tank. And so what you can do with something like this is you can basically have the vacuum pump there to like pull vacuum on the keg. I guess I'm not doing a very good job of this. So you like on the part that pulls suction, you'd have that come over to the keg. And then you'd have the keg come back here with a big old dump valve. Let's just say it goes to like there or something. And then you have a big old valve on here that you use to, I'll just draw it kind of down like this. You have a big old valve here that you would like crank over to one side. And then that's like how you pull hard vacuum at the end. So basically you still use the roughing, use the vacuum cleaner as like the roughing pump to get most of the volume out. And then as soon as this thing hits the top of travel, you want to open to this like high vacuum tank to like really suck the rest of the air out of there. And that, you know, the value in that probably depends on how close the vacuum cleaner gets you, right? And how fast it gets you there. Because like if it's within a PSI of vacuum, then you're not really going to get that much more like force out of adding that second tank. But if you're only getting to like, you know, halfway to vacuum or like a third of the way to vacuum, and you're pulling maybe like 5 PSI or 10 PSI out of there, then it's actually really nice to have that booster like reservoir, because that helps. Like an extra 5 PSI is huge. Like you only get 15 PSI from the Earth's atmosphere unless something really horrible has happened, like 14.7. So the only way to get better like definition and like pushing into every little crack of the mold is to have a pressure lid that goes on the top of this thing. But then it's like, if you've got 6 PSI in a vessel that big, that's a lot of stored energy. So you don't, you know, it's okay if it implodes. It's not okay if it explodes. Like that means it's coming out towards you. So that's sort of the tricky, like, you know, is the tricky part is you don't really know until you start fooling around with the specific geometry and materials that you're using without doing a lot of simulation. And I don't have any tools for simulation, so I'm probably not going to do that. So this is sort of a starting point, and you know, we'll kind of go from there. Like obviously there's some structure that's missing here. Like there need to be some linear rails and something to hold this oven up, and you know, we want to make this out of sheet metal if we could, and just angle iron that I can get cheap, because I'm trying to save money with this thing. What you make the bed out of is probably pretty interesting. Like you want something kind of lightweight. I've seen some cool expanded PVC foams that might work really well for that. I had a friend who's got a big sheet router who could help me out with like drilling 1,000 holes in one of them or something. But yeah, we'll see. It'll be interesting. So stay tuned, and I'll do another video kind of once I'm a little further along with the design. But thanks for watching.